Today is going to be 100-4, and what we're going to do is we're going to find the domain of logarithmic expressions. And so that's today's objective. We're going to find the domain of logarithmic expressions. Now going back to the properties, and the reason why I'm going back to the properties is because one of those properties of a log was the domain. And so if you look at the domain, it says the domain of our function when it's a log is from 0 to infinity. So we know there's values that aren't included there. They're excluded, which means that we have a domain restriction, right? I can't say -1 because -1 isn't from 0 to infinity. And so if you notice the numbers that are excluded, okay, so the numbers that are excluded, they're negative and 0, right? There's no bracket around the 0. It's excluded. So because the numbers that are excluded are -0, well, this is going to tell us two things for this. One, you can't have a negative or a 0 inside of a log. So if you ever do that, you see the contradiction to our domain, or the same with 0. But two, we can actually write a mathematical statement saying that, well, whatever's inside of the log, we have to say that it's going to be greater than 0. So you take whatever's inside the log and say that value has to be greater than 0. And we're going to use that to be able to find the domain of our logs. So first example, find the domain of this logarithm. Now from the previous properties we just talked about, we said that it can't be negative and it can't be 0. And we said that the inside of the logarithm can't be that. So creating a statement, we have to say whatever the inside of the logarithm is has to be greater than 0. Then this is a polynomial inequality. So the way that we solve or find the solutions to a polynomial inequality is we have to find the zeros, put them on the number line, and test the solutions. So I need to factor this. So this returns x plus 3, x plus 6. My zeros are x cannot equal -3. Now the reason why I say can't equal is because there's no equal to. So on the number line, we have -6 and -3, open circle and open circle. So now I have to test each region. So picking values, I can pick like -7, -5, and 0. So if I plug in -7, -4, and -1, negative and a negative gives me a positive. If I plug in -5, negative and a positive gives me a negative. If I plug in 0, a positive and a positive gives me a positive. So now the regions that represent my solution, because this does say greater than 0, numbers greater than 0, positive. So there's my solution, there's my solution. And so my domain is going to be from -infinity to -6, union from -3 all the way to positive infinity. And that's going to be my answer. For this next one, it says find the domain of the logarithm. Okay, so like we said previously, we have to take whatever the inside of the log is, set it greater than 0. Well, we can't factor that. It is quadratic. Maybe I can try solving for it. If I take the square, I get I. Well, can't do anything with that. It means there's no solution. So now I need to think of this analytically. We're saying values that are greater than 0. Values that are greater than 0. Okay, so that means I want positive values. And if I graph this, x squared plus 1, well, that's everything. Everything's above it. So in this instance, because everything's going to be above it, it's impossible for me to get a negative inside of my logarithm. My domain is going to be from -infinity to positive infinity, because it's impossible for me to get a negative. No matter what value, if I plug in a negative value, because I'm squaring it, it's going to be positive. If I plug in 0, I still get a +1. And if I plug in a positive number, I still get an even bigger positive number. So it's impossible for me to get a negative. And so therefore, there's no contradiction there in the analysis, meaning am I going to get a negative or a 0 inside of my log? So my domain is going to be negative infinity to positive infinity. Now this next one, because I have two separate logs, we're going to learn actually a trick on how to combine these together very shortly. But for now, remember, we have to look at both domains simultaneously. So I have to look at both of them. So each one, this has to be greater than 0. And then this has to be greater than 0. So now solving for both of them, I have x is greater than x, because if I add the x to both sides, and then if I add 4 to both sides, x has to be greater than 4. So I need to graph both of these on the number line. Here's 4, here's 7. They both have open circle. At 7, it says 7 is greater than x. So that means that it's going to go this way, because 7 has to be the largest number. This one says x is greater than 4, so open circle here, that's going to go this way. Now the domain is the intersection of the two. So where do they overlap? They overlap from here to here. And so my domain is going to be from 4 to 7. Now we can kind of test values here. If I plug in, let's say 2 or 3. If I plug in 3, well, it's going to be true here. 7 is greater than 3, but it's going to be false here. 3 is greater than 4. If I plug in 5, 7 is less than 5, which is true. 5 is greater than 4, that's true. Then if I plug in a value like 8, 7 is greater than 8, that's false. That doesn't work, contradiction. So therefore, we found our solution set here. So our domain is going to be from 4 to 7. So in conclusion, what concepts were discussed today, and how would you be able to describe the domain of a logarithmic function? I want you guys to go ahead and share what you've learned today in the comments. Well, this does conclude our lesson. If you do have any other questions, please leave them in the comments.